Now I will quickly walk you through our folder structure where we have four models, feed-forward neural network with two hidden layers. Then we implemented logistic regression with cross entropy loss for linear models. And for autoencoder, we have one hidden layer. And for autoencoder with supervised head, uh, we are taking encoded features as input, and this model takes a trained autoencoder and adds a neural network on top of its encoded layer for prediction tasks. And this is our classic 5x2 tenfold cross validation split for stratified for classification. I trained three models per fold. As we can see over here, that we also have uh, feed forward neural network for classification and regression. Then we'll have autoencoder with supervised head classification and regression functions. And I'm computing the accuracy for both classification and root mean squared error for regression. And in this function, we are running the 5x2 cross validation split, and we are generating all the results for demonstration. As you can see, this is the training loop that was generated, and this is the summary of classification and regression datasets. So this is for all the classification datasets. We have the linear accuracy, feed forward neural network accuracy. Then likewise for regression, we have the squared error for linear as well as feed forward neural networks. So these are the results after the 5x2 cross validation training split. Now coming to our notebook for demonstration of our program. Over here in this cell, I'm loading our six data sets. Then we are cleaning the data sets and label encoding the categorical columns, and numerical features were normalized using min-max scaling. Now in this cell, to demonstrate one complete train test split, I'll now demonstrate a single fold from the 5 by 2 cross validation. Here I'm using the breast cancer dataset. During training, you can see the logistic regression loss starting near 0 0.7 and gradually decreasing below 0.13 from here over here. After 60 epochs, as you can see over here. Yeah. So after 60 epochs, the logistic model reaches about 97.7% accuracy. The two-layer feed-forward neural network reaches around 96% here, and the auto-encoded head will reach around 96.8%. These numbers are consistent with the averages we saw earlier, confirming reproducibility across folds. And next, for a regression example, here's one fold from the Avalon dataset. We report root mean squared error, or RMSA, instead of accuracy. The linear model achieves around 2.21, the FFN achieves around 2.20, and autoencoded head model performs slightly worse, around 2.36. Again, this matches the trend from our full 5x2 cross-validation results. The feed-forward neural network and the linear model perform comparably, while the autoencoder shows a mild performance drop. Um, Now let's look inside each network to verify the forward propagation. For the logistic model, we compute raw logics and convert them to probabilities using softmax. In the feed-forward network, we print the first and second layer activations, both the raw inputs and the 10H transformed outputs, followed by the final logics. This confirms each layer correctly passes information forward. For the autoencoder, we feed a single example and compare it with its first five uh, input features to the reconstructed output. The close match shows the encoding and decoding work as intended, as we can see. And now I'm demonstrating one mini batch gradient update for each model. For logistic regression, the loss drops from around 0.72 to 0.54 with measurable changes in both weights and biases. Uh, then in the two-layer feed-forward network, the loss decreases slightly, and we we see non-zero updates across all three layers. Then finally, oh yes, for regression, again the feed-forward network shows the same pattern: loss reduction and active wait, as we can see over here. And then lastly, with the autoencoder, uh, the error improves from around 1.33 to 1.26 with both encoder and decoder weights updated, validating end-to-end learning. And this confirms that our full training and evaluation pipeline works correctly. Thank you.